Hey everyone, today we're going to start looking at 1.3 day 2, and this is all about quantitative data, specifically 5-number summaries, medians, and box plots. So let's get started on that now, and what you're going to notice is that I went ahead and took the set of data that we had from one of my classes, and I had them record a dot plot of their heights. Now the green check marks that you see there, that measurement, it comes from a girl in class, and the red X's are measurements that come from a boy in class. So the first question is median height, and how exactly do you find it? Well, we have a whole video on finding the median height, which I'll link somewhere in the corner here. And then we'll describe how we found it. Well, the median height, we found that the median height is 66 inches, and you find that by locating the center height measurement. So if you'll notice, somewhere in this 66 set of data, these 5 people, one of those is going to be the center measurement. If we stood every person up in a line from shortest to tallest, we would find that there is going to be one student who is in the middle, and that student in the middle would be 66 inches tall. So that is how we find the median. Now what about Q1 and Q3? How do we find those? We find that Q1 is 64 inches and Q3 is 68 inches. So the way to find that is to locate the center of the upper half of the data, which would be Q3, and then find the center of the lower half of the data, and that would be Q1. Incidentally, Q1 stands for quartile 1, so that gives you an idea, quart. So 25% of the data is below 64 inches, or 25% of the heights are less than 64 inches. And for Q3, that's quartile 3, so 75% of the heights, 75% of the students have a height that is 68 inches or less. So it's the center of the upper half and lower half. Again, if you don't know what I'm talking about, look at that video for the median, and that'll help us find it, or help you find it anyways. Next on our list, number 4, is to record the following values and use them to make a box plot. Well, one at a time here, folks. Let's figure out the minimum, Q1, median, Q3, and maximum. We'll just type those out right now. Okay, we have with us right now, we've got the minimum is 62 inches, Q1 is 64 inches, we did that just now. Median is 66 inches, and Q3 is 68 inches, and our maximum is 73 inches. And now we're going to make our box plot. So what I'm going to do for the box plot is I'm going to locate each one of these 5 numbers. These 5 numbers are often called the 5-number summary. So 62, 64, 66, and 68, and 73. That's our 5-number summary. And we're going to graph them on the number line with a vertical line like that. So there's 62. Here's 64, vertical line. 66, put us a vertical line over 66. 68 over here, another vertical line. And 73, we put a vertical line there. Okay. So you're just graphing that 5-number summary. Now you're going to connect the median and Q1 with a line segment, a horizontal line segment, like that. And then you're going to connect Q3 with the maximum with a horizontal line segment as well. So let's see if I can get that. Okay, that's not that bad. So there's that. And then lastly, you're going to connect Q1 and Q3 and the median to form what's, it's a box. And that's the box that gives us the word box plot. So here's our box plot. I know in elementary school and middle school, they'll often call this the box and whiskers plot, We're not going to be that cutesy here. It's just the box plot. So the IQR is defined as Q3 minus Q1, and that's an important measurement because it tells you where the middle concentration of the heights are located. So this tells me that the middle 50% of heights of my students are somewhere between 68 and 64 inches, or maybe I should say 64 and 68 inches tall. The length of that is 4 inches, so most of my students are in a 4-inch set of heights that is centered at 66. Now, the box plot, the IQR, is Q3 minus Q1. And if this is Q3 here and this is Q1 here, then the length of this box, however long that box is, from 68 to 64, that's going to be IQR. So IQR is the length of that central box. An outlier is a data value that's either way too big or way too small, according to the rules that we see below. So are there any outliers? Well, way too small would be any of the heights that are less than Q1 minus 1.5 IQR. That seems kind of arbitrary, and I agree, it is kind of arbitrary, that 1.5 part. But it kind of makes a little bit of sense because a height that's way too small should be pretty small in comparison to Q1. Okay, so let's see. Are there any of those? Way too big would mean that we have a height that is bigger than Q3 plus 1.5 IQR. And so for the same reasons, that kind of makes sense as well. So to compute this, the first thing we're going to look at is what is 1.5 times the IQR? And if the IQR is 4, 1.5 times 4 is 6. We're going to take that 6 and we're going to subtract it from Q1. So way too small would be smaller than 64 minus 6. So anything smaller than a height of 58 would be considered a low outlier. And if I look here, the minimum is 62, so there are no outliers. Nothing is below 62, so certainly none of the heights are less than 58. So that means we have no low outliers. Same way with high outliers. Way too big is greater than 68 plus 6. That turns out to be 74. And since our tallest person was 73 inches tall, there's definitely no one taller than 64 or 74, which means we have no high outliers. No outliers in either direction. So that is taking a look at the whole class data. What I'm going to do is I'm going to take a look at the data for the females, and we'll put those together. We'll write them down first. What are the female heights? Okay, so here is our female heights separated out from the whole class. And let's separate this into a lower half and an upper half. How many females do we have here? We've got 1, 2, 3, 4. Looks like we have 14 females. So that separates nice and evenly. The lower 7 heights will be the lower half, and then the upper 7 heights will be the upper half of the female heights. Now that we're separated into lower half and upper half, the median is going to be somewhere between let me just say it's right around here, between 65 and 65. And so since it's the same number, that tells me that the median height is 65. Now that I've got a median height, let's try to find the center of the lower half of the data. We said there were 7 heights in the lower half of the data. So if I think about 7, that would mean that the middle should be the 4th fourth height. So let's see if we can find the fourth height. So we notice that 63 looks to be the center of the lower half of the data. You've got 3 of the lower half heights below 63. You've got 3 of the lower half heights above 63. So 63 is our Q1 score. We might as well fill out the minimum and the maximum while we're here. So all we need to find in our 5-number summary is that Q3 score. And since Q1 and the lower half and the upper half are symmetric, then we really should be finding the, it's going to be 3 heights, then the median, then another 3 heights. Let's look at that graphically. So here we go. We got 3 of the upper half heights are less than 66. 3 of the upper half heights are greater than 66. So 66 is our Q3 height. Let's do a quick outlier check. Our IQR is 63 minus 66. 1.5 IQR is then 4.5, which is 3 times 1.5. And so let's subtract that from Q1. Q1 minus 4.5 is, oh my gosh, 68.5. Do we have any... No, I got that totally wrong. 63 minus 4.5. Well, that's 58.5. And we can see none of the heights of the females are less than 68.5, so we have no low outliers. What about high outliers? Way too high would be greater than 66 plus 4.5. So 66 plus 4.5, that is 70.5. And do we have any heights greater than 70.5? Yeah, we do. 73 is the biggest, is bigger than 70.5. So we're going to star this because this is an outlier observation. It's way too big. Is 69 an outlier observation? No, it's not. 69 is the biggest observation that's not an outlier. So in this case, we're actually going to make a modification to our box plot. So let's start off by plotting our 62, our minimum, Q1, median, and Q3. And what we're going to do is we're going to look for the biggest height that is not an outlier, and that is 69. 69 is our biggest one that is not an outlier. And 73, we're going to denote that 73 is an outlier by putting a star at 73. Just like before, we're going to draw the whiskers and the boxes, and there is our box plot for the females. Remember, 69 is the biggest non-outlier. Okay. Now we can do the same thing for males. I'm going to do it very quickly just so you can kind of see how this data stacks up. Here's our 5-number summary. A quick check of IQR tells us that a height less than 60.5 is an outlier and a height greater than 76.5 is an outlier. I don't see any of that, so the males have no outliers. And we get a box plot that looks like this. Looking at these two box plots together, it looks like the male height pattern is definitely, shifted to the right from the females. So that tells me that on average, the males are taller than the females, which should make kind of sense. Also, if I stack this up, notice right over here, this is the median of the males. Now, the median of the males, notice that most of the female box plot is less than the median of males. So more than, if each one of these parts is about 25% of the females, that's 25% 50%, 75% of the females are more than 75%, or at least 75% of the females have a height that is smaller than 68. So at least 75% of the females have a height that is smaller than the median of the males. And that's interesting to look at. Now, when we compare the distributions of girls and boys, we're going to go over those same 4 things from the previous lesson, namely the distribution, the shape of the distributions, the outliers, whether or not there are, is there a center, or what are the centers, which have a higher center and which has a variability. Now naturally, since we're looking at box plots, it's easiest for us to compare medians for the center and to compare the IQR for the variability. So we have the shape. Well, the women's distribution of heights looks kind of right skewed, and you can tell it's kind of right skewed because this distance from the median to the maximum measurement is much greater than this measurement from the median to the minimum measurement. So if we take a look at that tail, compare that with this tail, okay, that yellow one is definitely smaller than the blue one. So we would say that this is indicative of a right skewed distribution. Looking at the heights of the males, okay, we're going to compare the distance from the median to the maximum with the distance between the median and the minimum, and we're going to decide which one of those is bigger, or are they about the same. Well, it looks as though this has a little bit of right skew, but I don't think it's really dramatic enough for us to say there's a right skewed. So maybe a slight right skewed distribution might be the way that you'd want to describe this. Well, when we did this in the class, we said that the distribution of women was right skewed and the distribution of men is left skewed. And again, we did that in class. I'm not quite sure about that. I would say that this is approximately symmetric. So, fixing something we did in class. What about the outliers? Yes, there was a high outlier for the women's set, no outliers for the men's. The men have a higher median than the women, that is 68 versus 65. And the men have greater variability than the women, although it's pretty close, 4 inches to 3 inches. Make sure you use comparative language, and make sure you talk about shape, outliers, center, and variability. That's SOCV. Let's take a look next at our big ideas from this section. Firstly, the 5-number summary is the minimum, Q1, the median, Q3, and the maximum. You're going to use those 5 numbers, the 5-number summary, to make a box plot. For outliers, way too small means that we are less than 1.5, we are less than Q1 minus 1.5 IQR. Way too big would be any measurement or height in this case that is greater than Q3 plus 1.5 times IQR. And lastly here, to describe, remember SOCV, shape, outliers, center, and variability. You'll need to write about all 4 of those things to correctly compare 2 distributions. Remember to add that with context, and if I didn't say it enough, remember to compare, don't list. So that is the end of what we're talking about today. You have a Check Your Understanding, which you should be able to look at the answer key at the class notebook. But that's it for 1.3. Good luck, everyone, and I'm looking at the wrong place. Good luck, everyone, and we'll see you next time in class.